So this is very similar to what we're doing in our lab. We have a titration of KHP. KHP is potassium hydrogen phthalate. This is not phosphorus. So this group here is phthalate, which is the P, okay? And we like to use this because it's a solid acid. We can weigh it, and then we're going to titrate it with a solution of sodium hydroxide, our strong base. So our question is, if I take, let's say I take 0.724 grams of KHP, and I titrate it with some amount of NaOH. So I take this NaOH, I go ahead and I do my titration. How do I get the concentration of this NaOH solution? Okay, so my data I have here is I started with 58.8 milliliters of NaOH. I drip this down, it goes in here until we reach something called the equivalence point. The end point or the equivalence point is the end point, which is also called the equivalence point. That is when this turns pink. So I do this, I drop it down until it hits 24, it turns pink, and then I go, okay, well, I'm done. So now my question is, I know this much NaOH went in there, how do I get the concentration of that? So my milliliters here, well, I started with this, I ended with this. How do I get the number of milliliters? I take those two things, I subtract them. So 58.8 minus 24, that gives me 34.8 milliliters. So subtract those two numbers. And now we can do some math. So what I have to know, one thing you got to know about this, whenever I titrate something at the equivalence point, moles of OH minus, that's my base, so this is my base, equals moles of H plus. Okay, so this thing here is really important. Moles of acid equals moles of base. H plus and OH minus got to be the same. So, you know, my equation here, if I look at my chemical equation, and this thing right here, so if I have, you know, KHP, I'm just going to abbreviate KHP plus NaOH. If I'm writing that out, I want to see how these are related. Well, the K plus and HP negative, this is my acid. Okay, so kind of weird to have a negative charge for the acid, but the HP is all together. Plus Na plus OH minus. And, well, the K and the OH, not going to react. K and Na also not going to react, okay? In this case, the acid and the OH are going to react. And your net ionic equation is kind of funky here, but it's going to be hydrogen phthalate, HP negative, plus my OH minus, because this has got H in it, and OH want to react together. So what's it going to form? Well, we always form water. So I'm going to form water, H2O, or HOH, plus, and this thing ends up being phthalate, the 2 minus charge now. Okay, so, you know, K can't react with OH because alkali metal. Na, also alkali metal. And so these are the only two things left over. So this is, remember, this is not phosphorus, phthalate, okay? Okay, so we have a 1-to-1 ratio. OH, HP, let's do some math. I have 0.724 grams of KHP, and my molar mass is 204.22 grams. So 204.22 grams, 1 mole of KHP, 0.724 by 204.22, and that gives me 0.003545 moles of KHP. Okay, remember this thing here, moles of OH equals moles of H plus, or moles of acid equals moles of base. That's what I really am going for here. So how is this all related? Well, if I have 0.003545 moles of KHP, for every mole of KHP, how much acid do I have? I have 1 mole of H plus. Okay? Okay, we're going to try this again. So, once again, my ratio of H plus to OH minus is 1-to-1. And now I need to figure out, well, how much OH do I have in my NaOH? So for every mole of OH minus, how much NaOH am I getting? That's also 1-to-1 ratio. So, you know, 1 NaOH gives me 1 OH minus. It may not always be a 1-to-1 ratio all the way across. So I'm showing you this because in some scenarios you might have, you know, one of these might be a 2-to-1 ratio or a 3-to-1 ratio. But in this case, my moles of KHP equal moles of NaOH. So it ends up being 0.003545 moles of NaOH. Okay, so everything cancels out. This cancels out. This cancels out. This cancels out. Now, how does that translate to molarity of NaOH? Well, I know that this is the moles of NaOH. And back here, we titrated with 34.8 milliliters. So I have 34.8 milliliters of NaOH. Well, that also equals 0.0348 liters. And remember, molarity equals moles over liters. So if I have the moles, I have the liters, I can just 0.003545 moles NaOH over my liters, 0.0348 liters. Go ahead and solve that. It ends up being 0.1019 moles per liter, or 0.1019 molar NaOH. Okay, so that is kind of what we did in the lab. We might have some other problems, which I'll do in other videos.